Hello dear students, we'll continue our discussion from module 6. So for today's discussion, let me take file management. A file is a named entity on a media card, magnetic disk, optical disk or system memory. A file contains data, characters and text. It may also have a mix of these. So a file is a named entity on a media card, magnetic disk, optical disk or system memory, and it may contain data, characters and text. And it is very necessary to organize the files in a systematic way using a set of command functions. Let me repeat once again. It is necessary to organize the files in a systematic way. So the file management functions provide functions for creation, deletion, read and write to the files, and also setting the pointer to the appropriate location for the next read or write. So these are some of the command functions, that is open, write, read, LC and close. Now we'll move on to the different abstractions of a file. A file, as I have said earlier, a file may be a named entity, that is structured record named entity as on a disk having random access in the system. Second point may be a structured record on a RAM. It is analogous to a disk and may also be either separately called as RAM disk or simply as a file itself. Third point may be an unstructured record of bits or bytes. Fourth point, a file device may be a pipe-like device. A file device may be a pipe-like device. Now we will move on to the types of file system. Mainly we have got two different types of filing system, that is block file system, or we can call it as record file system, and the second classification is byte stream file system. So block file system and the second one byte stream file system. Now we will see the first one, block file system, or it is also called as record file system. In block file system, records are saved to memory. These records are first structured into a suitable format and then translated into block streams. A file pointer points to a block from the start to the end of the file. So that means a file pointer points to the start of a block to the end of the particular block. Now we'll move on to the second classification, that is byte stream file system. In byte stream file system, also the records are saved to memory. Its application generates record streams. These are first structured into a suitable format and then translated into byte streams. A file pointer points to a byte from the start, index equal to 0, to the last one, that is n-1 in a file of n bytes. Why is it till n-1? Since it is starting from 0. That is why it is ending till n-1. So let me say once again, byte stream file system. The records are saved to memory. Its application generates record streams. These are first structured into a suitable format and then translated into byte streams. A file pointer points to a byte from the start to the end of the file. Now we will see file descriptor. Similar to the processor descriptor at PCB, let me say once again, similar to the process descriptor at the process control block, a file system has a data structure called file descriptor, shortly called as FD. That is, the FD points to the data structure of the file. Let me say once again, similar to the processor descriptor at PCB, process control block, a file system also have a data structure called as file descriptor. It is shortly called as FD, file descriptor. That is, the FD, file descriptor, points to the data structure of the file. Now we will see the data structure of the file descriptor in a typical file system has identity information, creator or owner information, state, logs and protection fields, file information, sharing permission, count and storing media details. Let me say once again, the data structure of the file descriptor in a typical file system has identity, creator or owner, state, log and protection field, file information, sharing permission, count, finally storing media details. So these are the data structure of the file descriptor in a particular file system. Now we will see each data field in the file descriptor in a detailed way. So the name of the file is being indicated in identity field. The name of the file is indicated in identity field. The second point, the process or program by which it was created. The process or program by which it was created in creator or owner field. Third point, in state field, a state can be a closed, archived, open executing file or open file for additions. The fourth point, logs and protection field. In log and protection field, we have got three different classifications. That they are open file with read and write permission, open with read only permission, open file with write only permission. They are O underscore RDWR read or write, O underscore RD only read only, the other one last one O underscore write only WR only. So these are the three log and protection, different logs and protection. The fifth one, file information. This file information contains the current length of the file and when it was created, modified and last accessed. So the file information field contains the current length of the file and when it was created, modified and last accessed. And the sixth point, sharing permission. It can be shared for executing, reading or writing. Sharing permission means can be shared for executing, reading or for writing. Then the next one, count. Count indicates the number of directions referring to it. The count indicates the number of directions referring to it. Then the last one, storing media details. Storing the media details. So blocks transferable per access. It indicates blocks transferable per access. So these are the file data structure in the file descriptor. Now we'll move on to embedded system, flash memory, file systems. Embedded system, flash memory, file system. So, a flash memory card store files in mobile phones and digital cameras. So, that means a flash memory card stores files in mobile phones and digital cameras. For example, this generally we can call it as mobile phones and digital cameras generally called as an embedded system. And it consists of number of sectors of memory, and one full sector or block is erased at an instant. A flash memory consists of number of sectors of memory, and one full sector or a block can be erased at an instant. Now, file system requirement for flash memory. When a flash memory store is updated, the file system should write a new copy of the changed data over to a fresh sector and map the file pointers again. Let me say once again, when a flash memory store is updated, the file system should write a new copy of the changed data over to a fresh sector and map the file pointers again. The second point, the file system should provide for atomicity of operation even during power failure. So, atomicity in database management means a series of operations that cannot occur partially. It can either occur fully or not at all or not occur at all. Let me say one second point. The file system should provide for atomicity of operation even during power failure. So, atomicity in database management means a series of operations that cannot occur partially. It can either occur fully or not occur at all. The third point it is support for multiple concurrent transactions on the file. The third point, let me repeat once again, support for multiple concurrent transactions on the file. So, what do you mean by transactions? A transaction means read and write or erase a sector and then write the bytes into the erased sector. Transaction means read and write or erasing a sector and then write the bytes into the erased sector. The fourth point, support to wearing out of the flash devices. Support to wearing out of the flash devices. Because each sector can be erased only limited number of times, after which the sector becomes inerasable and hence not writable. So, that is the fourth point. So, I hope you understood what is a file management system and how a file is being organized and the various two different types of file systems and file descriptor, and finally the embedded system, flash memory, file system. So, thank you.